PS1 is due today or tomorrow if you take one of your late days. PS2 will be out tomorrow and be due next week. Any questions about PS1 or anything else before we proceed? Yes? Okay, start again. Say it louder.
Sometimes there's new lines added by the Windows shell when you put out to the console. You have to worry about that, or just have it contained what's supposed to be.
Okay, new lines are put out by the shell.
Yes. No, it's not like a Unix shell where it's just adds shell on and updates there. So, like if you have like 1, 2, 3, sometimes you make a new line.
Well, what I got to say is most of the questions I have to do with testing it in a window where you are in a shell where you are typing input and seeing output. And of course, it gets all mangled up. Okay? That's because you're using the same window for both. Just take your filter, pipe a file through it, and see what comes out. You'll just see the output then. And it needs to be like, as I expect. So like if you do format 3 and pipe a file through it, what ought to come out is 3 words, 3 words, 3 words, 3 words, 3 words, and maybe 2 words at the end. The only other thing is, make sure that you're outputting lines as soon as you can. No holding back all the lines until the end of file is reached. As soon as you have a line of output to write it. Don't save it. Yeah?
Do we have to write them like a whole line at a time, or can we just write each word as we go through?
Yeah, optionally, if you don't want to write a line at a time, you can write in format, you're asking. You can write out a word at a time, as long as you don't put a new line out,
Right.
except every third word. And again, for every n words. Right. Again, you know, the way we're going to grade is by piping a file through it and see what comes out. So make sure what comes out that way is right. You see all kinds of weird things when you're typing or cutting and pasting into the shell window and it's simultaneously doing input and output. It gets mixed up and looks weird. Yeah.
So I'm still a little confused about the format thing. So if we put in, let's say, like a 5-word sentence, and then you just press enter, would it just type 3 words? So it's format 3. Is it 3 words and then it would be 2 words, or would it be 3 words, Control Z, and then 2 words?
Either one.
Either one works.
The 2 rules are better. When I pipe a file into it, what comes out ought to look right, and it should output a line as soon as it can. If it's read 3 words, they should be, or n words, they should be output. It shouldn't hold them up for later. Any other questions? Okay. So in the lab yesterday, you began learning how to use Git. And I thought I'd give you just a small demo today of one way you can use Git. So let me turn off that. No? Yeah, I want the edge of it. Okay, so I have a repository called examples, and we're looking at it here on, I'm at the GitHub webpage. So our organization is U of U CS3500 S19, and we're at the only examples webpage. We're in the examples repository, and it shows you what's in it. It shows you on the master branch. It shows you that it contains a folder called features, a .gitignore file, and a repeat file. Features is a solution. So what I'll be doing is, when I come to class, I will typically have some code I want to show you. So today it's the feature solution. And I store it in the repository. So all you have to do, if you want to access it, is go to Visual Studio, come here to clone. It says enter the URL, so it's always going to be https://github.com, U of U, CS3500, S19/examples. So that's the name of that's the URL of my repository. And clone it. Okay, so it's cloned that repo on my computer. Now suppose this is you, and you've done that clone, and then Tuesday I use a new example, and I say it's in the examples repository. What should you do? Because you won't have it, you just have features. What should you do to get the repository? Right, you just need to do a pull. So go to Team Explorer, we're in the examples repository, we go to sync, and we do a pull. And it's already up to date. So just after every lecture, do a pull. It really confounds me when students come in my office to ask me questions about stuff I did in lecture, and they don't even have the examples repository on their laptop. Why? It's so easy. Just do a pull every time I make a change, and you'll have your code right there to use. Another thing that confounds me is what I find, I'll say, did you look at the code from lecture? And students will do this. Oh, yeah, this is what I did. I went to GitHub, and I clicked on features, and I clicked on delegates, and oh, and there's the file, and there it is. And I'll say, did you run the code? And they say, yeah. What I did was I selected it and copied it and pasted it into Visual Studio. What the heck? Don't be afraid of Git. Just do a pull. Okay? So don't be that person. Okay, so once it's pulled, so when I click on that little plug thing, you know that you're seeing all the repositories that I have. So I have a demo 1 and a demo 2 that you used in the lab. I have examples. Examples S17 is examples from last year that you won't have, but that I do. Okay, so one is highlight, means you're working in it. So if we go back, we'll click on the little house and end up over here, what you're going to see below it are the solutions it contains. Visual Studio is showing you the solutions that are contained in that repository. So if I want to use the features, I just double click on it, and then I go from the Team Explorer pane to Solution Explorer, and now I'm in the right place in the repo. Okay? So pretty easy to do. Now, what I want to do first is tell you what our workflow is going to be like. What it's going to be like working on assignments from now on. Oops, that's not what I want to do. Let me present. Okay, so I'm going to have a public read-only repository on GitHub called Spreadsheet. And it will contain, what I'll do initially for the next assignment, PS2, it will create a solution called Spreadsheet. It'll have a solution called Spreadsheet in it. And that solution will be empty. There'll be no projects in it. That's sort of the starting point. So what you'll need to do is clone it. You can call it whatever you want on your machine. I'll call it SS here. So you clone it. And now our two repositories are the same. And PS1 will say to, PS2 rather, will say to add a project to the spreadsheet repo, to the spreadsheet solution. So the first thing you have to do after you pull it is turn around and push it up to GitHub into your private repo. So you have, each of you after the lab yesterday, have a repo that begins with you. That's sort of the place you put stuff that we're going to be grading. So you have that repository. It's empty right now, so you just you push it up there from Visual Studio, and now it's up on GitHub. And so after, when you get started, you're going to set up this connection so you've got it working in both places. And you can, of course, you can clone it onto other computers if you want to. Doesn't matter. All right, so that's the first step. Then when I assign PS2, I will create a branch. So this has all happened on the master branch. What I'm going to do is create a branch called PS2. And it'll contain two projects. So what I'll do is I will branch my repo. I'll call the branch PS2. Then I will, on that branch, I will create two projects. I think one's a test project, one is the actual project you're developing. And that will be on my spreadsheet repo on GitHub. And you're going to need to fetch and pull, fetch from the repo to find out about the new branch, pull the branch down, and for the PS2, you work on that branch. So essentially, every assignment I give you will be on a different branch. PS2 is on the PS2 branch, PS3 is on the PS3 branch, and so on. Now, what I recommend you do is I want your final answer to be on the PS2 branch. So the safest thing to do is as soon as you get the PS2 branch, branch it yourself. Call it PS2 work or something and start working on it. So if you screw up at some point, you can always abandon that branch and start over if you don't want to figure out how to revert. But when you're done, you can merge it with the PS2 branch, and the merging will be automatic because no other changes will have been made on the PS2 branch. You should commit periodically to GitHub so that you don't lose anything if your computer crashes or something. Maybe I make a mistake. So I might make a mistake and send an announcement and say, ooh, I made a mistake in one of the projects I gave your PS2. And what you'll have to do then is pull that down and merge it with what you're doing. And that might take a little bit of, you might have to actually do a real merge then. There might be a conflict. But that way you get the changes into your code. And then when you're done, you just need to be sure that you push the final commit to GitHub. So what we want to see is the final version to be on the PS2 branch. That's your goal. Your PS2 branch, which you cloned from me, needs to contain a commit that is the thing you want us to grade. Now, every commit that you create has a hash value. The full hash value is like 80 characters long or something. GitHub will display maybe an 8 character, or even Visual Studio will display an 8 character hash. It uniquely identifies that commit. And you'll submit that hash on Canvas. You'll basically tell us which commit you want us to grade, which commit on your PS2 branch you want us to grade. And then when it comes time to grade, we just clone all your repos, pull out of the, pull the right commit and grade that. So to get your stuff working, at a minimum, you've got to at least push a commit on your PS2 branch. You need to ignore everything else I said. You'll have to be up on GitHub to get it graded. So you need to get comfortable with using Git, because it's just the way we'll work in the class. Now, the directions may change slightly. I'm considering using grade scope to grade your programs. I'll have to decide by tomorrow. If I do that, instead of submitting to Canvas, you'll be submitting to grade scope. That doesn't change the use of Git. Now, when we grade PS2s, we'll be using tests. And if this year is like other years, some of you will fail every single test. Or some of you will fail 75% of the test because you made a small mistake that caused you to fail all the tests. Maybe you changed the return type of a method. As a result, we can't link our tests. So we understand that. And so we have a regrade mechanism. So what will happen is, after the late submission deadline passes, I will add a new project on the PS2 branch, which will be the test we use for grading. And you'll be able to pull that down, merge it with your PS2 branch, and then you'll be able to run the grading test and see how you did. And at that point, you can, what you can do is, there'll be an assignment called PS2R, PS2 regrade. And PS2 regrade is your chance to tell us, yes, I just made this one small mistake, but it caused me to lose a disproportionate number of points. So if you make 10 mistakes and you fail 10 test cases, I call that fair. If you make one mistake and it's small and you fail 10 cases, that's not fair. So your job is to figure out, you have to debug your code, you have to correct it, and you have to push the corrected thing back up to GitHub. And then you have to fill out a form on Canvas that tells us which commit to look at and what you changed and what your mistakes were and stuff like that. And the TAs will judge then, okay, they fixed this mistake, now they passed these test cases, how much should I deduct for the mistake? So you sort of get the points for the test cases minus whatever the TA judges the severity of your error to have been. Yes.
So are you saying we're granted the test cases right at the beginning of the project?
No, at the end, you're given the grading test cases.
Oh, okay. Do we lose points for every grade?
Do you lose points for?
No, I mean like in the sense that we hold the regrade and now we're using the test cases to like look for, actually never mind. Ignore that.
Yeah, you, essentially, to get 100, you need to pass all the test cases, at a minimum, pass all the test cases the first time. If you don't, and you ask for a regrade and you pass all the test cases, that's fine, but you won't get 100. There'll be some deduction made for the changes you made to pass the test cases. The deduction may be less than what it would have been, what it was originally. Yeah?
Does that count for any of your like late work at all, or is it, or like, is it considered like as late work, or?
Is what late work?
The regrading. Right. If you do the regrading, is it considered when your late work for an interest?
Yeah, what we wait until, okay, so the deadline for late hand-ins is Friday. So we release the test cases on Saturday. And then you can look and see why you failed test cases, and you've got some number of days to fix your problems and ask for a regrade.
I think you're asking if it consumes one of your late days because you
Oh,
return
no.
it in later.
No, it doesn't. No, it doesn't consume your late days to ask for a regrade. What it does do is it consumes the patience of the TAs if you abuse this system. So there'll be some minimum number of points deducted for a mistake. I forget. Let's say it's 3. I don't remember exactly. So if you lose 3 points and ask for a regrade, that's pointless, right? Because you're going to lose at least 3 points for a mistake, even if you correct it. And you know, I always threaten the students with, if you know, you could lose points on the regrade if you abuse the system. Let's suppose you make 2 mistakes, they're completely separate, and you failed 5 test cases and lost 5 points. Correct them and ask for a regrade. The TA says, okay, there's a mistake, minus 6. Okay? So the point from the regrade is not to get every single point back. It's when the grade you get is out of proportion to the mistake you made. So trivial mistakes that lead to large point deductions in testing. We're just talking about testing here. There's a way to get redress for it. It's not there so you can get 100 in every assignment. Yeah.
You said what I'm about to ask you like many times, so I'm just clarifying. You will post all of these files to the U1000X, and we'll pull all of it from that repository.
Yeah. Every scrap of code I give you will be on in the spreadsheet repository
Right.
on different branches.
So a spreadsheet repository, or so are you making? Is that like inside of our group on GitHub?
Well, okay. So the terminology is there's an organization, and that is CS 3500.
Yeah. I'm looking.
Blah blah blah. All of you are. If we can go look at the. Okay, so right here is our organization homepage. And you can see that there are 192 teams. So there's 192 people registered for the class. Each of you is a member of a team of 1. And each team has access to 2 repos, the one that starts with U, the one that starts with X. X is just to play around with, U is the one that we use for grading. Okay? You also see that only 158 people got so far in the lab yesterday as to join their team. So there's still 35 people out there somewhere that haven't done that step. 34. Okay, so everything, there'll be directions in the assignment, but I won't give you zipped up code. You'll have to pull it from one of the repos that belongs. You notice there are 388 repos here. One of them is called examples. Another will be called spreadsheet. Spreadsheet is where you pull assignment code from.
And so, and you'll just give us access to those repos as we need them?
Yeah, that spreadsheet's public.
Oh, I don't see this.
It's not there. I haven't given you an assignment yet.
It will be.
It'll be there tomorrow.
We'll put it up.
Yeah.
Okay, okay,
Okay, any other questions? See, I'm trying to, I mean, this is, the problem of managing all you programmers is a software engineering problem. And we're using Git to help manage the software engineering problem, of coordinating all your activities and letting me communicate with you, give code to you and so forth. Okay, so I think that is, I think I was out of workflow slides at that point. Yeah. So you can't get far without using Git and GitHub. Okay, let's look at some of the code in that features. So there is, I have a few more examples of delegates that I want to look at. Similar to what we looked at last time, but just to drive home the point. Here we are. Okay, so we saw something like this last time. You just see we're creating a list that contains some strings. And we looked at sorting last time. So right there where it says sort, right, there is a method in the string class called compare. We're just using that as the way to compare elements. So we're sorting using string.compare. So that's sort of default. And then we output, we join them together into a list and do the output. And you can see other ways to do the sorting. So what's going on here? The problem is it doesn't show you my highlighting very much. Anyway, what's happening on this line right here? What are we using to do the comparisons? Yeah.
We're using that little mini method you just created,
Okay.
using X and Y.
So here's a lambda. So this, what you're passing in here is a method that compares two strings and returns an integer. If the first string is less than the second string, you return a negative number. If they're the same, you return 0. If it's positive, you return, if they're greater than, you return a positive number. So in what sense are we doing the sort? We sort in one way up here using that string.compare method. How are we sorting here? Right, that's just a method that returns. You give it two strings, it returns the negative of string.compare of those two strings. So it just inverts the order. So I just cook up a method that's the opposite of string.compare. Yeah?
Why don't you just negative string.compare?
Well, okay, so you're asking why don't I just do that and this?
Right.
Well, what is that? Can you negate a method?
Oh,
Yeah, you can't negate a method. You can negate a number.
Is that,
darn it.
Okay.
does string.compare not,
Well,
you're passing a method.
What he's suggesting is doing this.
So if they're not calling a method the first time, you're just saying, use this method.
He's asking why not do this.
Negative string.compare.
Something like that. So what's the problem with that right there?
There's a red line underneath it.
Yeah? And what would it say if I hover my mouse over the red line? Yeah?
Well, in the way we're calling it here, we're passing a method to list.sort, where in the top one we're defining a method which is equal to the output being whatever you would call string.compare x, y, and making it negative. So, right?
That's what we're doing here, is
Yeah,
we're creating a new
there we're
method that returns the negative of whatever compare returns.
Yeah, but because we're not calling the actual method string.compare, we can't.
Right. You can't negate a number. I mean, you can't negate a method. You can negate the result of calling a method. That's what we're doing there. You can't just say, what does it mean to put a negative sign in front of a method? And let's see what it says here. It says, operator negative cannot be applied to operand of type method group. Okay, so you can't do that. So we have to create a method that takes two parameters then calls string.compare those two parameters and negates the result and returns that. And that will cause the sort in the opposite order. Okay, here I've created a method called opCompare down here. So this is the same idea, but not using the lambda, just defining a method, and then we call it up here. So we're up here, call opCompare, and we defined opCompare down here. And that's just a heavier weight solution. You got to define this. Now you're obligated to give it documentation, even though you only plan to use it once. So why not just use the lambda instead? And we saw this last time too. This sorts by length right here. We pass in a method that takes the two strings, and all it does is returns the result of subtracting the length of one from the string from the length of the other, and then it'll sort the strings by their length. So just more lambdas. Okay? Here's a method called longer than 5. What does it do? You give it a string, what does it do?
Check if it's longer than 1.
It returns true if it has more than 5 characters and returns false otherwise. So that's a simple method. And here's a delegate declaration at the very top up there. And we're saying a finder is anything that takes a string and returns a Boolean. So look at this iterator right here in the middle. It's taking a list and a finder. So what does it do? What does it do when you give it a list of strings and some sort of finder? In particular, what if you passed it longer than 5? Suppose you called filter list with a list of strings and you passed longer than 5 as the second parameter.
That applies finder to each element in the,
Say again?
it applies the method finder to every element in the list string.
Right. So it's iterating through all the strings in the list. It applies the method f, the finder, to the string. If it returns true, it yields s. Otherwise, it goes to the next string. So this just enumerates all the strings in the list that pass this test. So it's sort of a combination. There's an iterator that's taking a delegate as a parameter. Yeah?
What does yield do?
What does yield do? It says this is the next item in the enumeration. So it returns an IEnumerable. So it's returning a collection of things, an ordered collection of things, and that just identifies the next thing. And the other thing to remember is that when you say this is the next thing, this execution pauses, and the loop that is consuming this thing gets a chance to run and do something with this element, and then it picks up where it left off until it yields the next one. Once you can only put yield return in something that returns IEnumerable. And you can't put a regular old return. It has to be yield return. Thank you. Yes?
What would the syntax be if you were just passing longer than 5 instead of finder now? Like, how do those two things relate? Like, what is that?
Well, this is just a parameter list here. All right?
Yeah, so the first one is fine.
Okay. Well, let's go look down here.
Well, I see.
Here we go. So it says, let me put, it's at the top now. We're calling filter list, we're passing it a list and a method. We're saying, give me back everything in this list that's longer than 5. Now, what do you make of this method here? There's a method called, okay, one here. What does this method do? It returns a finder, right? It returns a method. It creates a method and returns it. Okay? You write methods to compute integers and return them, compute doubles, to compute lists. This computes a method. You just have to get used to the fact that methods are values. And what method does it return? Yeah?
It's the finder where whatever int x you give it, it will only find the values that have a length longer than that.
Right. So we supply the x. Let's say we supply 10. It's going to return a method that takes in a string and returns true if that string is longer than 10 characters and returns false otherwise. So we're returning a method. Yeah?
Is the word finder the name of the method as we've defined it, or is that a type of method?
No, finder is a type.
It's
Right?
a
This
type.
is the return type. Finder is the type, the return type of the method. It's defined up here somewhere. Right? Right there at the top of the
Oh,
screen.
that's right, okay.
A finder is a method that takes a string and returns a boolean. That's just a type of this kind of
That's
delegate.
because we defined it as a, okay.
Yeah, that's just something we define. Okay, so let's see what we can do now. Okay, I'll put it at the top of the screen so we can talk about it. There we're filtering the list with the finder that we obtained by calling make longer than x. So now what that's going to do is give us back the strings that are longer than 10 characters. Yeah?
Wait, so we're allowed to define our own types, or method types?
You're allowed to define your own, to name your own delegate types, yeah. Yeah. Notice how we did it. We had to use the keyword delegate in there. Yeah?
Can you store in a numeral? Can you do like var ABC is equal to?
Sure.
Yeah.
Yeah, so it's an object, you can store it. The only things you can do to an IEnumerable object are ask, is there a next element?
Okay.
Or ask it to move to the next element, and then ask it what that element is.
Okay.
And that's exactly what's needed to write a for each loop that consumes an IEnumerable. But you can use it outside of a loop, but only using those two things. Let's see what else you can do. What am I doing here? Oh, let's look up there. It says finder f1 equals longer than 5. I'm just storing the method longer than 5 in a variable f1. And then the next line I call it. So why not? If you can store an int, why not store a method? Here, I am just declaring f2 a different way. Rather than saying finder, I'm saying a function that takes a string and returns a boolean. Here, what am I doing here in this line?
Passing method.
I'm creating a method, storing it in a variable, and then calling it right there. So you just have to sort of open your mind to the possibilities. Yeah.
Where you were storing it, where you go down and you were storing it in the finder variable,
Mm-hmm.
you were storing the lambda expression. Now if the lambda expression didn't match, like it didn't return the correct object,
Sure, if it's not the correct object, I think that's a type error.
would the compiler complain?
Sure.
Oh, okay.
Let's do this. I'm going to make this take 2 parameters. It doesn't like that. It says, finder does not take 2 arguments. It just wants a 1 argument thing. But let me correct something you said. It is not storing this lambda in that variable. What's it doing? I'm being really picky here about that.
Storing a reference to that?
Well, it had to do with references. Yeah? Oh, yeah, someone said it. It's evaluating this, obtaining a method, and storing the method in the variable. It's just like if I do this. It's not storing the expression 2 plus 2 in the variable. It's evaluating that expression, obtaining 4, and storing 4 in the variable. So it evaluates the lambda, it evaluates to a method. The method is stored in the variable. Really doesn't make a lot of difference, but that's just, if you want to be picky, that's what's happening. Yeah?
So when we're declaring that method or that lambda,
Mm-hmm.
we don't have to put any variable types because a finder type has already, so it's assuming that S is going to be a string because that's what we define finder
Yeah,
as.
the compiler has to be able to figure it out. And so what the compiler does in this case, it says, okay, that parameter S has to be compatible with finder. Finder expects a string, that has to be a string.
Could we, when you declare lambda, can you specify?
Yeah, I think, I don't do it all that much. Let's see what we do. Yeah, you can declare types if you want to. Sometimes you might have to.
If it makes it easier to.
Yeah, maybe the compiler complains they can't figure out what you mean, so you have to declare it. But,
Well, I was thinking for like later purposes, when we're coming back trying to figure out.
yeah, that's just as documentation, I suppose. Yeah. Yeah.
Wait, so in that line, when you're basically declaring a method,
Mhm.
you use s as the variable, and then you're using s inside there. It's like s.length.
Yeah, that's what methods do. They take parameters and they use them in the body of the method.
Well, I wasn't finished.
Oh.
But, when you use s, but if you were to add another variable n, you would also have to use n in there. It'd have to be like
No,
this.
the problem is, if I change this to, suppose I did this. Suppose I said this takes two parameters and reports whether or not the first parameter has the same value as the second parameter. I mean, whether s.length is in.
Oh,
The problem isn't that I have two parameters, or that I wasn't using in, it's that this is incompatible with Finder. Finder expects a single parameter method. Yeah?
So if you're gonna overload like the method to like take more variables than you want to put in, so like say like you declare like a bunch of, would you have to do multiple finder?
Yeah, you'd have to have different, yeah, you'd have to have a different type for different numbers of
So you
parameters.
name them the same, like finder, this thing takes in like string, and then this thing takes in a string of pool.
Well, if you want to do something like that, you have to go up here to Finder, and you have to make Finder generic. Where did I declare Finder? So I don't remember how to do that. Let's see. This is how it works. So now I've got a generic delegate type. And so now I would do finder of string, or finder of int, or finder of list, or whatever. Yeah.
Is there a generic way to say, like, rather than take one parameter, to take like n?
No, there's no generic way to say finder of some number of strings. You'd have to have separate, you know,
Overloaded? Can you make overloaded delegates?
you'd have to say, yeah, I think you would declare finder of t comma r or something, and then you'd have that. Finder of t1, t2. They've got to put it back the way it was, or the stuff, the code that was there won't compile, unless I change it all. Yeah?
The open brace statement defines string dualism. So you would not need to have finder declared anywhere above that to use it. That's like a way to. That's like
This
a way-
here, yeah. That's just another way to declare, to say the same thing.
but That's like you're making the delegate there.
I'm just declaring it there.
That's not dependent on finder.
No,
existing anywhere.
I wouldn't have to have finder to do this.
So the reason you would do that is if you only needed to do it once, and you would make delegate,
Right.
you make a whole bunch of.
Right, right. But you know, if I'm going to use finder, if I'm going to end up putting this in several places, it's nice just to give it a name. Okay, so it's just more examples. And you see we're sort of mixing up delegates and iterators and even generics there. So if you use a language that, to me, an ideal language is one that doesn't put restrictions. It doesn't say you can use generics unless they're, you know, you can't use a primitive type. That's what Java says, right? You can't use a primitive type to instantiate a generic. So it's sort of this, you got these two separate concepts that you aren't able to combine without restriction. So it's nice when you have a language that says, okay, you got generics, you got iterators, you got delegates, they combine, there are no restrictions. You just combine them in a natural fashion. And they do what you would expect, and you don't run up against arbitrary restrictions. No. That's what we're seeing here. Okay, let's get out of that. And we're going to look at, we're going to take a break, and then we're going to look at something else. So we'll take a couple minutes off. Okay, so I just want to show you this while I'm thinking about it. So I made some changes to that file we were looking at, and I didn't mean, I was editing and taking out. And I wonder if I broke it somehow, if it was in the shape I wanted it to be when lecture started. I'm not sure what shape it's in now. So I can go up here to Solution, right-click, and there's an Undo option. And it says, are you sure you want to undo your pending changes to these two items? So I changed a couple of source files. So I can, so if I realize I've just screwed up since the last commit was created, I can just say yes, and it's gone. That's sort of the easiest way to undo things. You have to get, it's more involved when you made a commit, you want to undo it, you want to revert the commit. Just getting rid of changes since the last commit is simple. So when was the last commit? You never saw me make a commit, so how far back did that undo to? What do you think?
Computer says 23 hours ago, at least from when I pulled it down and started looking.
Okay, so from the standpoint of the repo I'm in right now, it was when I pulled the latest commit when I cloned. So it just went back to whatever it was when I pulled it down. You watched me pull it down. It was created 23 hours ago by me, but so I'm back to the original state. So it's just something to keep track of if some night you want to do that. Okay. We're going to look at some other aspects of C# that are different than they are in Java. So here we have a class, person1. A person has a name and a person has an age. And then there's a constructor that sets them. Now, I'm sure you've been told not to write code like this when you learn about Java. What's wrong with this class? Yeah?
The class variables are public.
Right, the instance variables, the member variables, the class variables, whatever you want to call them, they're public. And hopefully someone drilled into your head they should be private. Why is that? Why should instance variables be private? Yeah?
Because they shouldn't be able to be seen out of the class. if they're
Well,
used.
yeah, we don't want them to be seen from outside of class, but why is that? Yeah.
So you can't modify them?
Okay, we don't want people from outside the class to be able to modify them. Yeah?
Basically, when you create a method, you want to control anybody's interaction with whatever your variables are, so that way you can control what
Yeah.
they can do with them.
So you can think of your instance variables as being how you've got some idea of how you plan to use your instance variables. You only want your methods to be able to change them. Someone from the outside may not respect your wishes when they change it. Another reason you make them private is so you can change your mind later. Maybe decide, I want to use a different representation. Suppose your instance variable holds a list. And you decide, no, I'm going to replace this with a set. Well, if you've made that list visible by making a public instance variable that contains that list, your clients are dependent on it. They're expecting there to be that instance variable there. And if you change it to a set, it's going to break all their code. So that's the reason we make things private. So how do we get away? How do we make it private? And by making it public, people can access name and age, right? They can find out the name, they can set the name. And you see how that works up here in the main. We create P1 here, we can set the name to Jill, we can write out the age. What happens when we make these private, though? What do you do when name and age become private? You need getters and setters. Right? So there we have private age, private name, constructor's the same. Now there's a getAge method, a getName method, a setAge method, and a setName method. And the methods are public, but the representation isn't. So you can change your mind about the representation. If you decide you want different instance variables, you can. You just have to re-implement your methods and no one's code breaks. But what's the problem with this?
There's a lot of stuff you want.
That's a lot to write, a lot of code to write and document and test. That sure seems more succinct, this here. But it has that problem that once these appear in the interface, we can't change the way they behave. We're stuck with them. Well, C# solves that problem.
Great.
Okay? These look like instance variables, but they're not. They're called properties. So what you see here is we're creating a public property called name. That property will contain a string, and you are allowed to get the value and set the value. The same thing for age. You're allowed to get and set. Now, that class, this thing here, person 3 class, is going to be indistinguishable from the point of view of the user from person 1. The property is going to look just like an instance variable, and you access it the same way. So if we go up here to where we use it, here's person 3. We create a person, we set its name to Jill, we write out the age. It doesn't look any different from person 1 here, where we did the same thing the same way. So properties are designed to look like, you access them like instance variables. So how is that an improvement on instance variables? If they look the same and behave the same way, provide the same abilities. Is it just changing the name somehow makes them okay?
You can change your stuff and not break everything.
Okay, so he said you can change your stuff and not break anything. It turns out that with properties, you can customize what happens. You can customize what happens when one of these properties is set. So a property is sort of like a combination of an instance variable and a getter and a setter, except you do a lot less, you enter a lot less code to do it. So it combines getter, setter, instance variable all into one thing. So if what you really want are public getters and setters, that's what you do. Where are we? Right here. You declare properties. Now, you should not make all your instance variables properties. Properties tend to be what does property suggest to you, the term property?
The barcode.
Barcode?
A part, like a portion of it, like a part of it.
Okay, a part, sure.
It's an element you can change in it.
Some element that's intended to be changed, yeah.
So could we create that and not say set and just say get?
Yep, if you left off the set,
Now
now you have get, they can be obtained, but not, it turns off the ability to change them. So it makes the set private, the get public. Yeah?
I don't know if we're gonna cover this, but how do you access those? Do you access
You access them just like instance variables.
So, okay, so you wouldn't do like dot get or anything like that?
Well, from outside the class, you would say object dot name or object dot age. Inside the class, you could just say name and age. Yeah?
Property implies some sort of ownership.
He said property defines some kind of ownership. I ask you because I'm not exactly sure how to characterize it. But as we see more examples of properties, you sort of get the idea. You wouldn't make a set, say you're implementing a not a binary search tree, a hash table. You wouldn't make the array that contains the buckets in the hash table a property. That's not something you expect to access as a property. It's things like names and ages and colors and fonts and sizes and things like that. Things for which you would typically create getters and setters. That's what properties are for. Okay, here's another way to customize visibility. We can say, okay, it's a public property, but the setter is private. Okay, so we could use it inside the class. We could use this property. Outside the class, you can't. Or, this is the other thing that makes this an improvement over making instance variables public, is you can customize what they do. So here, we're just saying name is a public property. Anyone can get the value. Only code inside the class can set it. Then we say, this looks big because of the way Visual Studio uses braces. What this is saying is, there's a getter and a setter. If you set the property, what it does is it says, if value is less than 0, well, what the heck's value? It's obviously a keyword.
Is it what they input?
Right, it's the thing they're trying to set the property to. So if the incoming value is less than 0, throw an exception. So this would prevent setting an age to a negative number. Otherwise, save it away in an instance variable. So I declared an instance variable somewhere. Where is it? Up here. Private instance variable at the top. And then if someone asks to get the age, we just return the value of the instance variable. So you could not pull that trick if age and name, forget underscore age, if age and name are instance variables, there's no way you could customize what happens when the instance variable is set. But here you can. So you can change your mind about, yes, you're sort of stuck with this property in your interface. if you want to keep your clients happy, but you can change the behavior, you can customize the behavior. So just keep in mind what I said was the property sort of combines into one thing, instance variable with a getter and a setter. And if what you want is just private getter, public getter, private setter, it's really easy to do. Otherwise, if you want something different, yeah, you got to write some code. We're basically customizing the getter and the setter there. Yeah.
So if you had declared it and just omitted the set part like we had talked about before, could I not now change it within my own method?
That's a good question. He's asking what happens if I do that out. Am I now not allowed to set it at all in my code? And obviously I am. So I'm not sure if that's any different from that. But let's make sure.
Wait, how did you check it?
I just saved it and I noticed it didn't display any errors. Because right here I'm setting it. Name gets in. So I guess that amounts to the same thing. But you could also declare it protected, for example. Protected setter. So they're not hard. I'll tell you the hardest thing that would happen is I have in the past asked people to, without thinking, to create a property called value, which just ain't going to work because value is a keyword. And it's really confusing when you do that. And it's flagging an error somewhere. So anyway, yeah, don't make a property called value because the keyword value is the name for the incoming thing to the setter. So you'll see tons of properties. So you just know what they are now. When you look at the API, the .NET libraries, properties are used left and right. All right, here's another cool thing. Extension methods. Look right up here where it says console.writeLine, blah, 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 and we're calling 15.gcd of 9. What the heck? There are a couple of things going on. First of all, what you think of as primitives have methods in C#. Why not? Other values can have methods. So you've got methods like equals, get hash code, get type, toString, and so forth. So you can invoke methods. Yeah?
So then what's the difference between a capital S string and a lowercase s string?
Okay, yes, what's the difference between capital S string and lowercase s string? Some types have two names in C#. I won't explain it right now. But
Well, they both have access to the same
they amount to the same thing. So like int, another name for int is int32, capital INT 32. Another name for lowercase string is uppercase string. And so what happens is I try to remember to use lowercase string in C#, but since I program so much in Java, it's a losing battle. But fortunately, either one works. But look, there's this method called GCD. Now, does it seem odd that's the only method for ints that's not sort of one of these built-in, equals, get hash code, and so forth? Why isn't there a square root method or a square method? The answer is, I added that method to int myself. So in C# you can create what are called extension methods. You can take a class that someone else wrote, that's in the library, and effectively add methods to it without having to have access to the code of the class. The only catch is, you don't get access to the internals of the class. You don't get access to instance variables that are private. So let's see how I did that. How did I arrange for ints to have a GCD method? What am I doing here? Let's go down. Here is where I do it. So let's look at it like this for right now. That is just a static GCD method. It takes two ints and computes the greatest common divisor. And I'm not worried about the algorithm. It just works. But you can see it's called GCD. It takes an int A and an int B and returns an int. To turn it into an extension method, all I do is I put the keyword this before the first parameter. And and boom, it's an extension method. And I believe it has to also be in a static class, so yes. The class that contains an extension method must be a static class, i.e. it can't define a type. It has to just contain static methods. So, okay, that's another use of the keyword this. But what do you suppose happens when I put this in front of the first parameter? What does it mean? What does the C# compiler do? Yeah.
Is it taking it and using it as a method for that first parameter?
Right. What it's saying is, instead of calling it the usual way, which would just be GCD of 3, 15, it says when I call it, I want to call it using method call syntax. So it would be 3.gcd of 15. That's all it does. It changes the way you call it. It makes it look like you're calling a built-in method, even though you're just calling a method, just a plain old static method. So you'll see that if I take this out and go up here to where I called it the first time, it's saying, int does not contain a definition for GCD and no accessible extension method exists. I could have called it like this. And to be truthful, that's how I don't think it's particularly useful to add that as an extension method to int. I think it's more natural to call it that way. But just to show you what's possible, you can effectively add a method to the class. I just have to remember to say this. Yeah?
Is the scope just like regular scope where any ints within this, whatever?
Yeah, all right, it's the scope within this class, but also if this class is imported, if it's in a namespace, if you use the namespace in another file, then it's accessible there too. It's just like any other method. The answer is, suppose you took this out and you asked the question, where is this method visible? And you gave an answer. The same answer works here. Where is this method? It's still visible in the same places. It doesn't make it any less visible because you declared an extension method. And you notice that when you declare the extension method, it shows up in the IntelliSense. That's neat. Makes it more apparent. Let's look at another one. Let's see, what was the first one I did? Okay, I have a method called list.render. So render is an extension method. And let's see what it does. It's a generic extension method, because why not? It takes in, the first parameter is a list of keys. It takes that list, and the join method joins the elements of the list together, pins them together with spaces in between. And then we put square brackets around it. And now we have this method, and because we put the keyword this right here, people are going to see it when they have a list and they hit dot. IntelliSense will show them the method exists, and they can call it as a method instead of as a static method, which it really is. So I wouldn't say this is a reason to ditch Java and use C#, anything like that. This isn't like a huge game changer. It's just sort of a neat thing. And when you use IntelliSense, it actually puts a little decoration on the extension methods. If you go and you look at the list class, use IntelliSense to see what methods there are, you'll see that I bet more than half of them are extension methods. So they're not defined inside the class, they're defined outside the class as extension methods. What advantage can you see for that? Yeah?
It's kind of in the name. You can extend the available methods you have for a class.
You can extend, but why not build them into the class in the first place, since presumably you're the one creating the class? Why did .NET decide to define the majority of the methods on lists outside the class as extension methods instead of inside the class? You got an idea?
Yeah, maybe it only applies to a specific range of programs or something that they might want to use that for. Whereas they want to make the rest of them more generic.
Well, okay, so he's postulating, he's wondering if maybe the extension methods are only intended to be used in certain contexts and not in others, but I don't think that's the reason. Yeah?
Maybe if you have like a bunch of people working on a group project and do the extension methods, it's less likely to cause merge conflicts.
Okay, he's talking about causing maintenance problem with merge conflicts. I think that's getting closer. Yeah.
Could you overload the extension to take a different class?
Could you overload the extensions? Well, you could. I guess you could define different extensions. I don't know about overloading them. Well, it really doesn't have to do with overloading. What's easier to write? A method in a class or a static method outside of a class? What's harder, classes or static methods? You learn static methods first. You know, at 1410, I spend the first half of the semester on static methods. Then we introduce classes and the trouble really starts. Okay? Because static methods inside of a class, they have to deal with the instance variables and they have to cooperate with each other on the instance variables. Methods outside have a much simpler view. They can't mess around the instance variables. So if you can take all the code out of the class that doesn't need access to the instance variables, that can get by with calling the methods that do use the instance variables, that simplifies the class. It simplifies testing it. It simplifies maintenance. And now you just have to maintain some static methods that are external. And yet, because they're extension methods, they might as well be built-in methods. So I think it's just a way of, as all good programming language features, the reason is to make life simpler for programmers, especially for large programs. So for what it's worth, extension methods. We won't make a ton of we won't write many extension methods, but you'll certainly use them, whether you realize it or not. All right, now we're going to look at parameter passing in C#. So here we have this method try parse. And it says int32.tryparse. Like I said, that's a synonym for int. No, that didn't work. I could have just typed int.tryparse. Anyway, it's a static method. And it takes two parameters. It takes a string to be parsed. And what is that second parameter?
The output.
Right. A parse method really needs to return two things. It needs to return the result of parsing the number, parsing the string. So in this case, it want to return a 45. But it also needs to tell you if the parse succeeded. So suppose we had a parse method that just took the string, like in Java, just takes the string and returns an int. How do you find out that the parse failed? How do you learn that the string did not parse to an int? Yeah?
False.
Well, returning an int. I'm not talking about this. I'm talking about if we had in Java, the parse integer method in Java.
Throw an exception.
It throws an exception. Okay? So another way to think of a method like this is, it'd be nice if you could return two things. A Boolean saying whether or not the parse failed or succeeded, and the integer, which is the result of the parse.
If
and
it succeeded.
This is the integer, which is, so in this case, it would return true because the parse succeeded. And what it does is it stores the 45 into that variable right there. So we say if the parse succeeds, then we can access the value because the value got set. Otherwise, we print out parse failed. So this is called an out parameter. You put the keyword out in front of the parameter name, in front of the variable there. We're saying it's an out parameter. And what's different from an out parameter from any other parameter? What if I just put value right here? Okay? When you do that, you're just passing the value of value to the method. When you put out in front of it, you're giving the method access to this local variable. So the method running over here can come down and change the value of this local variable because we said out. Can you do that in Java? No. So this is an example of what's called call by reference. We're not passing the value of the variable as a parameter. We're passing a reference to the variable as a parameter. Yeah?
Could we declare that variable as well? Can you just do out int value?
No, he asked, could you just say out int value? I don't think so. Seems like I get asked this every year. Let me comment that out and see if that's how about that? That's nice. I'll just leave that there. Yeah?
Does it matter what type of method we use with that, or is it just anything that returns value for the out?
Okay, so the question is, under what circumstances can you use the keyword out? So I'm going to go back the way I had it so I can make these changes more easily.
Does that just make it local to like that if statement? Or can you...
I suspect doing it the way I just deleted makes it local to the if statement. So if you want to use it after the if, you would have to declare it the way I originally had it. It's not enough to put out in front of the parameter. So first of all, when you pass an out parameter, you can't pass 2 as an out parameter. What's wrong with that? Yeah?
Isn't that just saying the values to automatically?
Well, what's supposed to happen to an out parameter when you pass it?
2 is not a valuable
Right.
variable name.
The code, try parse is not going to be able to come down here and change 2 to something. So the thing you pass as an out parameter has to be a variable or an array location or something like that, something that can be changed via assignment. Okay? So we're going to pass value. Second of all, try parse is written in its header. It says, it declares that second parameter as an out parameter. So you can't just decide, I'm going to pass this as an out parameter to this other method. The method has to be written so that it accepts an out parameter. And in fact, you can't leave the out off. If we look at the error now, it's going to say, argument 2 must be passed with the out keyword. There's no choice. If you look at try parse here, it tells you, you probably can't read that, that the second parameter is an out parameter. So the method has to say, I'm expecting an out parameter, and you have to say, I'm giving you an out parameter. Both sides have to cooperate to make this work. So you'll see out parameters a lot. And again, that's an example of call by reference. A lot of times you'll hear people say that Java uses call by reference. No. Java uses call by value. Yes, it passes references to objects as parameters, but that's a different sense of the word. Reference is used in a different sense than it's used here. Here we're talking about references to variables, not references to the heap. So in C# you can choose whether to use call by value, which is what you're used to, and call by reference, which is what out is. Okay. Here's a method I wrote. Let's go down and find the method. It solves quadratic equations. You give it, quadratic equation is the form ax squared plus bx plus c. So I give it the coefficients to a quadratic equation. And you know that a quadratic equation, if you're looking for real roots, there can be 2 roots, 1 root, or no roots, just depending on the coefficients. So what does the method return? Forget about the out parameters there. What does it return? It returns an int, which is the number of roots. So it tells you how many roots there were. And then, if there were no roots, x1 and x2, okay, first of all, you're required, you have, the value that comes into as an out parameter has to be, you cannot use its value in this method. And you have to give it a value before you return. So I'm storing 0 in both of them to satisfy that condition. And then I look at the discriminant, and if there are no roots, I return 0. If there is 1 root, I store it in x1, and then return 1. And if there's 2, I store it in x1 and x2, and then return. So back where I called it, I call it, I get the value of roots. If there is 0, I say no roots. If there's 1, I can pull the value out of x, because that was passed as the out parameter, or otherwise I get the value out of x and y. So I can return, I'm returning 3 things. 2 roots and the number, up to 2 roots and the number of roots there really are. Call by reference again. Yeah?
If there's only 1, are you setting x and y both to that, or only x?
Well, you got x and y up there. The 4th and 5th parameters are x and y. Down here in the method, the 4th and 5th parameters are x1 and x2. So when I store to x1 down in this method, what I'm really doing is storing to x up here. And similarly with y. I store to x2 in that method. It's storing through to x2. You have a question?
Is there any reason why you did like a bunch of else if statements rather than a switch, or is that just a matter of...
Oh, I could have used a switch. Yeah, there's no reason.
So essentially it lets you return more than one.
Yeah, it lets you return more than one thing. That's what out parameters are for. Yeah?
But are out parameters designed so that you can as the client program so that you can go and affect those variables and such as
Well,
well?
no, it's not two ways.
There's only one.
It's one way. The method I'm calling will be able to change x and y here. Now, regular parameter passing, I'm effectively changing, I pass a value to a method, I'm changing the value of the parameter inside the method.
You're giving the slave method access to the users.
Yeah, I'm giving the method I'm calling access to these local variables, which you absolutely can't do in Java. Yeah?
So in your solve quadratic, if you tried to use x1 and x2, it would not allow you. You can only assign it values in your program, or can you use the value that exists there?
No, it cannot. The method down here that I'm implementing may not, you cannot, let's try to do it here. Let's say int z equals x1. Let's try to make use of the value of that parameter. Right? It's going to tell us you're using an unassigned out parameter. So the rule is, if I've declared out parameters, I must give them values before I return. And I cannot use the values they have when they come in. Now I'm trying to remember, let's try this. What if I give it a value? Okay, it lets me do that. But when I store 4 into x and I pass x as an out parameter, it's guaranteed to be overwritten before the method returns. So there's really no point to that assignment right there. Yeah?
Is that what gives the warning that forces you to use out, like we're seeing in the other, like the IntelliSense stuff, like of the
Right. So if I leave out, first if I look at IntelliSense, it tells me those last two parameters are out. And so you have to say, basically, when you put the out keyword at the end of call, you're saying, I realize this is an out parameter. Now, what if the language designers, they could have just said, okay, we know it's an out parameter, it's declared an out parameter. Why not just let people pass x and y without having to say, I realize this is an out parameter? Why make the programmer go the extra step of typing out? Because the programmer can look at IntelliSense and see it's an out parameter. Yeah?
It just seems like they're more likely to accidentally override something that they want.
Yes. It's just, it avoids accidents, it avoids misunderstandings. You'll see this a lot in C#. There'll often be times where something's declared here and you must acknowledge it here. So you have to be upfront that you realize that you're dealing with an out parameter. Otherwise, you could be surprised. All right, so that's an out parameter. Let's look at a different one. This is called a ref parameter. So ref parameters are another example of call by reference. The difference is they're not one way. With a ref parameter, the method you're calling gets access to the value of the parameter. It could also change it back at the point of call. So what do you think this method does here? I mean, that's standard swapping code, so it interchanges the values of n and m. Now, if this were Java and you took out the refs, or C# and you took out the refs, would there be any point to this method here? I mean, what would happen if we took out the refs and you just passed two integers to swap? It would swap the values of n and m in return, affecting nothing outside the method. Right? Nothing would be changed back at the point of call. But by making them ref parameters, when I assign to n, I'm actually assigning to some variable back at the point where this method was called. And the same thing goes with m. So let's go to where it was called. So look how I'm calling it. I'm saying swap a sub 0 and a sub 1. So the things you pass by reference don't have to be variables. They just have to be things that can be changed with assignment. So what's going to happen before, this is going to print out 2, 9. After, it's going to print out 9, 2. Because I passed these array locations by reference. And they get changed by the method. Notice the neat thing is the method says nothing about arrays. All it knows is it's getting a reference to a place where an int can be stored. And it's reading the ints out of one place and storing it in another. Yeah.
So in Java, if you passed arrays to methods, and you change stuff in the array, it would also change it, the original.
Well, yes, if we pass an array to a method,
Right, so my question is that the same thing here where arrays are? Do we have to specify ref in order to change an array?
no, not to change, if you're, the thing is, this method, we're not passing in an array, we're passing in
Right.
reference to array location.
I-
Yeah, it works the same way in Java as C#.
Okay, so the arrays are the same way?
Right.
Okay.
And I just want to emphasize, this isn't specific to arrays. I could say int A equals 7, int B equals 9, and then say swap ref A, ref B, and it'll interchange the values of A and B for us. Yeah.
So it's basically just like taking those primitive types and then turning them into like a wrapper class.
Well, I wouldn't think of it as turning into, as passing objects or anything. It really is giving access to, I'm going to say one more thing, so don't leave just yet. Giving access to local variables or local locations to a remote method. Yeah.
Are references and pointers, is that the same thing, or?
In languages like, yeah, okay. When we talk about references to objects, those are like pointers. These are different kinds of references.
Okay.
Okay? I want to tell you one more reason for using call by reference. It turns out in C#, you can define new primitive types. Okay? In Java, you're stuck with like 7. Int, long, bool, whatever. In C#, you can find new primitive types. And those new primitive values can be really big things. And when you pass those by value, they're copied. So you could have a primitive value that's a megabyte big. You pass it by value, it gets copied. So call by reference is also used to avoid copying big things. Instead of passing the thing by value and having it be copied, you just pass it by reference. And then it's not copied. We'll see more about that in a couple of weeks.